Welcome back to the channel, Adventures Through Climate Change. That is correct. We are taking an armchair approach to figuring out what the heck is going on with climate change. Sitting in my chair and watching videos, really, and looking at stuff. A lot of statistics online, a lot of stuff. There's such conflicting points on a lot of issues, right? Like, what's the real cause? I think it was a couple days ago we looked at the Milankovitch cycle, right? But that's just a partial portion of what's going on. Today is one of the debates. I don't know what his premise is. I haven't watched this video yet. It says, is CO2 really a greenhouse gas? With that being a question mark, I'm going to say he's going to say no, it's not. It's from the Action Lab, which obviously they do a lot of videos. But is it not? I don't know. I've heard that it insulates. I heard that it reflects. It acts almost like an albedo, or not allowing as much in. Like the particles in the sky act to stop the rays going through. I don't know. I don't know what to think. But this is one of those things, and I know a lot of people are going to get mad at me because I have opinions about things. Yes, I watch a lot of videos. I read stuff, and yes, I have opinions, and I'm probably going to be wrong on most things, just like most human beings, because the smartest people in the world turned out to be wrong most of the time. So let's get into it, because I talk too much anyways.
We're going to be seeing if CO2 is really a greenhouse gas. And I'd like to thank Ren for sponsoring this video. Bill Nye famously did a video where he showed how to do a simple experiment to show how CO2 is a greenhouse gas. He said to grab 2 jars and fill one of them with air and the other one with CO2. Then put a thermometer in both of them and shine a heat lamp on both of them. He said within a few minutes you should see that the one with CO2 will rise in temperature faster than the one with air. So let's try this. So I have 2 identical jars here and 2 thermocouples in here. The readings are going right here. This top one, if I hold it, you can see the temperature go up. The one on the left is on the top, the one on the right is on the bottom here. So let's fill the left one with CO2. So the temperature went down a bit from the CO2 gas expanding in there out of the compressed cylinder. Let's just wait for it to equilibrate and get back to the same room temperature. Okay, they're now within half a degree of each other. One on the left's at 65.1 and the one on the right is 65.7. So now let's put our IR source. I'm going to put it directly in between them. Okay, I can feel the heat. Let's do a quick time lapse so we don't have to wait.
30 times speed. That's a decent amount of time.
So these are staying remarkably consistent to how they started. They started off about a half a degree difference between the two, and it's about that exact same difference right now, 10 degrees later. So they're consistently rising in temperature together. From what I can see, there's no difference between these 2 jars in the way that they're absorbing this IR light. So why didn't this work? Well, there's a lot wrong with this setup. The first thing is that the 2 jars are made of glass, and glass doesn't let IR through. You can see that when I take this IR camera, you can't see my hand behind this pane of glass.
I was actually going to say, how do you know the heat distribution is the same? What if there's a fan like on the other side over there and it's pushing heat one direction and only one's getting... Of course, they did it exactly. They went up the same and they were down the same, so I guess it wouldn't really matter, but that's interesting. So glass.
So the only reason they're rising in temperature right now is not because the gas inside is absorbing the IR light, but the glass is absorbing it, and the glass is heating up, and then that's heating up the air or the CO2 inside of these.
So the glass.
But another version of this experiment just shines regular light, not a heat lamp. In this case, you get a pretty significant difference between the CO2 and the air. But the reason that this happens is not because CO2 is absorbing infrared light, but it's because you're creating an actual greenhouse. The reason a greenhouse gets warm is mainly because it doesn't allow the warm air that gets heated up from the light to mix with the outside cooler air. So actually, if you used argon, which isn't even a greenhouse gas, you would still get significant heating, more than air. This is because argon and CO2 are both more dense than air. So in this type of setup, what you're actually measuring is the heat flow characteristics of the gas and the convection of the gas. So this is a really bad experiment to test whether or not CO2 is actually a greenhouse gas. We know this is true.
That's interesting, because I do remember a similar video, Bill Nye video, when I believe I was in high school. So this was pre-2000 maybe. And yeah, I'm not sure that they did the experiment or not now. I can't even remember, but if that experiment didn't work, I don't know what to say. And Bill Nye said it will work. I used to watch a lot of Bill Nye when I was in high school. Lazy teachers.
Because there have been a few published papers that show this type of setup shows heating of the CO2 that's way more than the theoretical heating possible due to CO2's absorption spectrum in the IR range. So overall, this method of showing that CO2 is a greenhouse gas by shining a light in a jar of CO2 just doesn't work. So how can we show that CO2 is a greenhouse gas? Well, being a greenhouse gas means that it absorbs infrared energy and eventually turns it into heat. So let's just focus on the part where
they'd have to find a different container would be my guess. Something that allows the rays to go through. I don't know.
It absorbs infrared light. I actually got the idea for this setup from a paper in the Journal of Chemical Education. I'm going to measure the temperature of my hot plate here using my infrared thermometer. So my hot plate back here is going to serve as an infrared source. And then I have an infrared thermometer here that's going to act as our infrared sensor. So we're going to see how much infrared light gets from the hot plate to the sensor here. The way this works is by measuring the amount of IR light that hits the sensor. The more intense the IR light, the higher the temperature. So if I stick something that blocks the IR light, I get a reading of a lower temperature on the hot plate. For example, if I stick a whole piece of glass in between, it absorbs all of the IR light from the hot plate. So the temperature is way lower, it's just reading the surface of the glass temperature. If I stick something like this screen in between, I get a reduced temperature because some of the IR light is getting blocked by the screen and some is getting through to the sensor here.
Makes sense.
So this mesh drops it to around 200 degrees Fahrenheit. So let's test what happens when I put a bag of CO2 in between here versus a bag of air.
A bag. The IR light can go through, apparently.
Okay, here's our CO2 bag. And here's our air bag. Okay, so I have my bag of CO2 and my bag of air here. Okay, so I have this aimed at the hot plate here. You can see where the laser's aiming. So first, let's see the temperature with air.
Okay.
We're reading around...
Okay, we're about 316. I just want to pause for a second. Maybe we have a little guess. Is it going to go up or going to go down? Hypothetically, I guess it wouldn't really even make sense when they say it insulates, because if it insulates, it would be hitting the hot. It wouldn't go through, right? Or I guess it wouldn't go through the other way, so that you'd have more insulation, which would keep it more insulated. So, but it would still be blocking it. So it should go down, I guess, right? It should go down.
315 degrees Fahrenheit. But with CO2, around 300 Fahrenheit, 305 Fahrenheit. Air, 315. CO2, 305. It's a huge difference. Air, CO2. Air, CO2. You can see that the CO2 showed a lower temperature on the hot plate. Now remember that we're using the IR thermometer as a measuring device of IR light. This isn't actually showing the temperature of the CO2 gas in between, it's showing the reading of the hot plate behind the CO2 gas. But since the CO2 is absorbing some of the IR...
So if you put that on a grand scale, then the sun's shining through the, I guess the ozone, right? And because there's more carbon dioxide, it's actually going to get cooler on the Earth with more carbon dioxide, which is opposite of what most things tell you with carbon dioxide. Most things tell you with more carbon dioxide, it actually heats up and insulates the world, right? Isn't that what I've always been told? It was warmer during the dinosaurs, or at least when there was more prevalent life and whatnot with more CO2 and whatnot, right? And it was warmer also. But they did say, Mr. Ellis did say that typically goes in correlation. Not always.
IR light, you get a lower reading than you should have had without the CO2 being there. This shows that the CO2 is actually absorbing the IR light. We've essentially just created a spectrometer here. I love this experiment because it doesn't depend on the heat flow characteristics of the bag. It doesn't depend on any other factors other than the absorption of infrared light. So it's a really easy setup with clear results too. It doesn't depend on where your thermocouple is exactly placed. It's a very clear distinction between CO2 and air. So we know there's not a question that CO2 is a greenhouse gas. The question is, what are we going to do about it? And that brings me to the sponsor for this video, REN. REN is a simple and effective way to reduce your personal CO2 emissions. On their website, you can calculate.
It's greenhouse gas. So what he's saying is it is because we're insulated and hotter here, it's preventing stuff from going out and making it hotter. Because with the greenhouse, like he established at the very beginning, it's covered, it's insulated, it's separate from the world. And so it'll have a tendency to have more CO2 and stay warmer. It's recirculated air, right?
Calculate your carbon footprint, then offset it by funding a diverse mix of carbon reduction projects like tree planting, mineral weathering, and rainforest protection. By answering a few questions about your lifestyle, you can find out your carbon footprint and how to reduce it. No one can reduce their carbon footprint to zero, so you can offset what you have left after reducing. Once you sign up to make a monthly contribution to offset your carbon footprint, you can receive monthly updates from your projects you support. You get to see what your money's spent on, with photos and details on every tree planted, every acre reforested, and every ton of carbon offset. One of the projects that's really exciting is how they're creating biochar in California. This helps reduce forest fires and provides a carbon capture method that keeps carbon locked up in the earth instead of the air. So if you want to help reduce the greenhouse effects of CO2 on the earth, you can go check out REN. The first 100 people who sign up using the link in the description will have 10 extra trees planted in their name. And thanks for watching another episode of the Action Lab. I hope you enjoyed it. If you did, don't forget to subscribe to.
I wish he was a little bit more clear on his premise at the end, or what exactly happened, because it seems so contradictory to me, because I think his premise was it does act like a greenhouse effect, which would warm everything inside, right? I mean, because if you're keeping already warmer weather inside, it will stay warmer. I guess I was confused because we need the IR light to warm up, right? So is that what happens? That it actually, like, it does create a warmer environment, but eventually you're not getting enough warmth in there to keep that warm environment, so it cools down, and that's how you get to the ice age? Interesting. This stuff is it's so interesting to learn, and there's so many different things, and I like that type of experiment. I really enjoyed that. I wish he would have had more of a conclusion at the end. Maybe he didn't have more of a conclusion of his own. Maybe he was leaving it up to the people watching the video to make the determinations of their own. I don't know. That's a fantastic way to go if that's the case. You guys know what to do. Please support me if you think it's okay. If you think my videos are all right, if you want me to keep making these, this is just a hobby. Hit the subscribe button, hit the like button, and any comments. Look, I don't care if you beat me up on it. I've gotten some pretty bad ones, some pretty good ones. It really doesn't bother me. I understand that some of the stuff I'm saying is controversial, and you're not gonna agree with me. And I think a lot of it comes down to, Are you on the Mother Earth side, which I feel like I can be too, or the humanitarian side, where you're just like, well, there's plenty of space for all of humankind. Yes, we need to do our part, but and be responsible and whatnot. But it's how it goes. It's how we were meant to live. I'm more on that end. So, anyways, I appreciate you all, and most importantly, we'll catch you on the next video.